Please join me in welcoming them to the stage.
Give them a minute to get this microphone. Can everybody hear me okay? Microphone coming through clear? Perfect. Thanks for being here today. I know South by is a busy time and you had other choices of places to be, and I'm grateful that you came here today. I believe I got here on purpose, and I don't know all the paths your life took you on to bring you to this room today at South by, but I'm going to treat you like you're here for a purpose, and I mean capital P purpose. What I want to talk about today is very important. I had a joke, and I decided not to tell the joke, so you'll never hear it, and so you'll never know if it was funny. I'm here today to talk about something that I believe is very important. And I hope by the end of this hour together, you will think it's very important. And I hope we will lean into the capital P purpose and resolve to do something about it. So, I believe that there is a time for everything. There's a time to plant. There's a time to harvest. There's a time to laugh. There's a time to be serious. There's a time to tell jokes. There's a time not to tell jokes. There's a time to walk. There's a time to run. There's a time to laugh. There's a time to cry. And I'm here to argue today to you all that it's time to build. And I mean quite literally buildings, homes, houses, neighborhoods, communities. I think the homes and buildings of our future are going to have to be profoundly different than they are today. Not a little bit different, profoundly different. In fact, if you offered me a 100-year-old home or a home built a year ago, odds are I would take the 100-year-old home. If you offered me a 30-year-old home or a home built a year ago, odds are I'd take the 30-year-old home. And that is a sad state of affairs. I can't think of any other industry for which you'd prefer the 100-year-old thing to the brand new thing. A lot of you are here today because you probably care about homelessness and the global housing crisis and the issues related to housing in the modern world. And I think it's even worse than you probably imagine. In the United States, we presently have 5 million fewer homes than we need, and we're building 2 million fewer than we need per year. So the hole gets 2 million homes deeper every year, presently. That lack of supply drives a lot of the other problems I'm about to talk about. So buckle up. As we try to dig ourselves out of this hole, we resort to less skilled sources of labor, less quality materials. We try to cut corners. We exclude design professionals from the process for very good reasons. But the result ends up being, unsurprisingly, rather monotonous, rather low quality, rather low resiliency, and what I'd say is like rather soulless housing. And of course, rightfully so, cities, municipalities, building regulatory authorities increase regulations because they want their cities and their towns to be beautiful, sustainable, lovely places to live. But those regulations make builders and developers have to resort to using design professionals even less frequently, to scaling the designs they already have, looking for lower quality sources of materials, sourcing labor anywhere they can get it, which in turn makes the cities regulate harder, right? That's what it is. Let's regulate harder. And this is what I call the housing doom loop. And we've got to break out of it. Construction, from an environmental perspective, is the #1 contributor to landfill waste. It's the #1 user of energy. It's the #2 user of water, unless you consider water used in energy production, in which case buildings are the #1 user of water. And the #1 source of atmospheric carbon is construction and buildings. Bet you didn't know all that. If we want to solve our ecological issues, we are going to have to find new ways to build. Not just a first world problem. Zoom out globally, 1.6 billion, with a B, of our sisters and brothers do not have housing and shelter that you would find adequate. And I know these are all big numbers I'm throwing out. If these were people that you knew and loved, you just would not stand for it. You would weep, you would take a second job, you would do whatever you had to do to change that situation, and we must change the situation. We must change the situation. We are going to have to innovate like our life depends on it. And I'm not talking about NFTs, and I'm not talking about a way to sell ads faster, and I'm not talking about getting a discount to your concert tickets. I'm talking about innovation like our lives depend on it, because there's not a bright human future if we can't shelter ourselves appropriately. Okay. And we're not even in the game. The things where, if I offered a $1 million prize to the people in this room to invent a less resilient, less durable, less healthy, less sustainable material than drywall, nobody would win the prize. We literally can't think of a way to do it worse. We can't think of a way to do it worse, and it's not because everybody's so wicked. It's because we don't know what to do, which means we've got to do something different. However scary, however unnormal, however unnatural, however surprising it feels, we've got to do something different. And it won't surprise you to hear by this point that when we build in hurricane zones, when we build in wildfire zones, in places prone to natural disasters, we actually use the same materials, the same processes, and the same approaches. Because that's how we are trying to solve the affordability problems. And this is just not working. We're going to have to try a radically different approach. So I'm not talking about figuring out how to frame faster. I'm not talking about hanging drywall faster. I'm not talking about robots that put on asphalt shingles on the roof. I'm talking radical difference. Sort of whether we like it or not, the future of the human condition depends on it. It's time to build, and it is time to find new ways to build. If you Google searched a 1,000-year-old house, I did. It's planed lumber and nails and bricks and stones and mortar. It's literally the same. I was making sure it wasn't CEO hyperbole because that happens sometimes. It's literally the same for 1,000 years. And it is time for the construction industry, the largest and I think most important. When building the world is a great responsibility. There ought to be like a Hippocratic oath, like doctors take. People who build things ought to have to take an oath. It is a great responsibility to build the world. And it's time for the built environment to join the digital automated robotic revolution that has brought so much good to other industries. So, I know that's the bad part. That's all the bad stuff. So I want everybody, literally I want you to breathe in, breathe out. What if we could build houses that were twice as good in half the time and at half the price? What kind of problems could we solve, and what kind of opportunities would open up before us, and what kind of world could we build if that's the way we were working and that's the way we were thinking? Humans are amazing. Life is a miracle, and we can do this. Where's Tomorrowland? Where's Wakanda? Where's Rivendell? Where's the things you know you wanted when you were a kid, and you need to want them right now? As a grown-up in this room, you need to want them right now, and you need to be prepared to scream and fight to get them. We want that world, and we need that world. It's a lot to do. Where do we start? We start with our first principles. We start with the things we want out of our homes. We believe in the inherent dignity of all human beings on this planet, and we want their housing to match that dignity. We want humans of every single socioeconomic background to be able to have a decent, dignified place to live. We think it is existentially urgent that we find ways to shelter ourselves that don't ruin the health of the planet we depend on. Beauty, dare I say it. We insist on the world that we build be beautiful, and it should be comfortable and safe to live in the world that we build. Let's start there and refuse to play these things off against each other. We must insist on having all of these things. And so that's why we started Icon. Icon is an advanced construction technologies company trying to put the things that we are inventing and building in service to humanity. We work deeply in three major areas: robotics, most notably and very charismatically the giant 3D printers that you're maybe familiar with at this point, software and advanced materials. Just so you know, this is real. For those of you who aren't familiar with Icon yet, this is our current Vulcan system. Out on the job site, it takes architecture, turns it into robotic construction, receives extrudable concrete that's made on demand, and layer by layer builds up a house in almost any shape you can imagine. If we build 100 homes in a row, 100 can be different. If you want a house in the shape of a Fibonacci spiral, we could print you one in the shape of a Fibonacci spiral. And if you want a house in the shape of a square, you're boring, but we can still build it for you. The current construction system was designed to deliver 95% of single-story homes on the planet. Pretty good place to start. We've developed construction operating systems to make it easy to operate these machines with tablets and phones. We've developed and are developing softwares for building information, design, permitting, regulation, project management, everything we can do to make it go faster at a higher quality and a more affordably. And we're inventing materials that from a first principles perspective are going to build stronger, more energy efficient, more resilient, more flexible opportunities to build than conventional approaches today. So ultimately, maybe there's approaches that do a few of these things, but only 3D printing. If we could find a better way, we would not be 3D printing. 3D printing is the best thing we can find. 3D printing is faster, not just because the sort of the obvious thing that it's automated. The machine can work 24 hours a day. It's very inhuman to ask builders to work 24 hours a day. You'll love this part. We've also designed the machine. It doesn't stop and text its friends. It doesn't check on the football scores. It doesn't drink any beer. Nothing like doesn't show up late. It just runs the file. Radically lowered the cost because the wall system, which we've automated today, is the most laborious, trade-intensive, and time-consuming part of the construction process, and it also creates the form of the home. So automating the wall system is just a very powerful place to start. We get to do all this without surrendering customizability. A lot of the other approaches have involved like prefab and modular houses. You guys have seen these things. The problem with that approach is you have to design the house to fit on a truck. Houses are not for trucks. Houses are for people. And this allows you to design with humans in mind rather than transportation in mind. We know how to industrially scale robotics, and you get a higher performance building. We've already talked about resiliency, but also concrete has a high thermal mass that makes these buildings very comfortable and energy efficient to operate, and the possibility of radically reducing construction waste. A lot of you in this room have probably been to a job site, and you sometimes will see there's more waste than house at the end. But with 3D printing, we have the possibility of printing what we need to the drop, and then we stop. And that's cool, not just because it rhymes, but because construction waste is a profound problem that if we could solve, would be a huge opportunity for humanity. So we got to work trying to make all this real. 4 years ago this week, we unveiled the first permitted 3D printed home in the world. I checked right before I came on stage, just 1 mile from where I'm standing right here. The first permitted 3D printed house in the world unveiled at South by 4 years ago. Very cool. We then put our services in partnership with a wonderful organization called Community First Village that's here in Central Texas. Yeah, give these folks a round of applause. Community First Village is one of the most important, innovative, and human-centric organizations working on the problem of chronic homelessness. They're doing it here in Central Texas. We delivered for them a welcome center and then a series of 6 homes. We printed the homes 3 at a time. All 3 homes had a different layout, floor plan, and orientation. Because with 3D printing, the architecture is digital. We have a lot more good work to do with Community First Village. We'll be announcing it soon. Stay tuned. We then went down to Mexico and delivered the first pilot 3D printed community. This was actually in a seismic zone. We printed these homes 2 at a time. These were family homes. And one of the things that has happened since then is Tabasco, Mexico, where we did the project, has received a magnitude 7.2, 7.4 earthquake that caused extensive regional damages. And the 3D printed houses were just fine, and the families that live there today are just fine, and how rarely that is the story for the very poor, who often bear the brunt of these things most profoundly. We're going to keep marching on with Newshour. We're going to keep marching on with Community First Village, but we wanted to open the aperture and tackle the global housing crisis on more fronts by doing our first market rate mainstream housing project here on 17th Street in East Austin. These were the first 3D printed homes to sell at market rates in the world to our knowledge. And it was the first time that my wife walked into a 3D printed home and goes, I'm ready to live in a 3D printed home. So I knew we were definitely on the right track. But something happens when you really radically change a paradigm. And I know that phrase paradigms or paradigm shift, those are like overused in startup world, I absolutely admit it. I think we deserve to talk about what Icon is doing as a paradigm shift. And when you shift paradigms, you not only can solve big problems, you get to pursue grand opportunities that were previously inconceivable. And of course, what I'm talking about is building humanity's first homes on other worlds. So literally a month after we did the Chacon house, the first house we ever did, we began partnering with NASA as part of the Artemis program to create an off-world construction system that we called Olympus to build the moon base. We asked NASA to give us the moon base plans so that we can get to work designing the machine. NASA didn't have moon base plans. It turns out, it's like, you're NASA, you're supposed to have a plan for the moon base. What are you doing? But we partnered with NASA and the Bjarke-Ingels group, some of our favorite architects on the world, and we designed what you're seeing here, a very robustly realistic way to deliver all the major elements of infrastructure for a moon base: landing pads, roadways, habitats, using local lunar materials and a single automated construction system. This is not the city on the moon in 1,000 years. This is the moon base we can build in our own lifetime, if we decide to. Johnson Space Center reached out, wants us to participate in research for the same kind of thing for a Martian exploration. Human space exploration is based at the Johnson Space Center in Houston, and so they're doing research on how long-duration space travel will affect human health and performance. And so we've built an analog Martian habitat at the Johnson Space Center. And so humans getting ready to live on other planets, that's going to happen inside 3D printed buildings designed by the Bjarke-Ingels group and delivered by Icon. That's really happening. And so all this is happening, and I hope what you're feeling is like, this is the kind of revolution we want. Like, this is the way. Affordable housing, accessible housing, beautiful housing, homes on other worlds. This is what we want. And I hope you're also feeling it wants to be very different. The housing wants to be very different. And so I've already talked to you guys about how we are innovating in robotics and software and advanced materials. We realized we needed to expand our imaginations a little further, push a little harder. We had one more thing that we needed to invent. We needed to invent architecture for robotic construction, for 3D printing, because what we've been doing to date is appropriating architectures and design languages that were designed for stick frame houses. And so by appropriating those too closely, we were appropriating some of the problems of those approaches. And so we worked with some of our favorite architects here in Texas, Lake Flato, and we said, we want a house that turns everything up to 11, that could only be 3D printed, and that uses all the strengths and advantages that robotic construction brings to bear. And we unveiled this house this year at South by Southwest, also 1 mile, I checked, from where I'm standing right now. This is the world's first home ever designed specifically to be built by a robot. And what you're seeing, you can see the incorporation of these organic and what I find to be lovely forms, but also those different forms. Like if I had a piece of paper and I stood it up here on the stage, it would fall over. If I fold it, it will stand up with no additional reinforcement or change in material properties. You can use those forms to create strength and structure. Also, we can make the walls thicker and more energy efficient and comfortable for the people. To double the energy performance of a conventionally constructed home and double its width, you double the price because you double the materials. With 3D printing, when you turn a corner, you go 6 inches further before you turn the corner again. It's basically a rounding error on price. So we're approaching something like getting passive house level energy performance, getting aggressively cool new architectures, getting much more structural resilience, basically for free. You sort of get that stuff for free with 3D printing. And we are really, really proud of this house. And it makes me feel like we need to be doing a lot more of this kind of innovation alongside the other innovation that we're doing. So where do we go now? Next up for Icon, we're ready to graduate from building a few homes at a time to literally building hundreds of homes at a time. In partnership with the largest, most innovative, most values-aligned production builder in America, Lennar, we, later this year, are going to begin delivery of the first 3D printed neighborhood in the history of the world. And it is going to blow people's mind. We can have this better world we want. We can have high design from the Bjarke-Ingels group. We can have all of this work out economically. We can have these neighborhoods be beautiful, and we can deliver it with robots, even in the middle of a labor and supply chain shortage. And this makes me excited, because if we can do 100, we can do 1,000. And if we can do 1,000, we can do 10,000. And Icon's goal right now is to get to where our technology is delivering a home per day. And then we go to a home per hour, and then we go to a home per minute, and then we got a home per second. I just gave you our whole business plan. Because at a home per second, we can solve the global housing crisis in our lifetime. We will see a new and better world with our own eyes. And I insist on it. If we have a 1 billion home shortage, to make that number even more depressing, that means Lennar is the largest builder in America. They build something like 70,000 homes a year. If we could build 1 million homes per year, more than an order of magnitude more, it would still take us 1,000 years to build 1 billion homes. That's 950 years too long. Only robots can do this. There are not enough humans who know how to build things to get us out of the problem that we're in. So we have so much yet to do, so much yet to invent, so much yet to explore. But I do want to just unpack quickly. You sort of get a sense of what it means to do it one house at a time. What about when you have robots at neighborhood scale? This is an overhead view of how you would typically do a 100-home community. Those are about 2,000 square feet house. There's 100 of them. You sort of get the idea. It's potentially very boring, potentially very soulless. Why did we get here? It's not because people are wicked. It's because this is how presently we would deliver affordable housing. This is our best shot. I think we would all agree this would be a much more interesting and compelling place to live. The cool thing about that picture is the same number of houses, same number of square footage for sale. With robots, diversity of construction is back on the menu. We can have the world we want, and in fact, I want us to insist on having the world that we want. So much more to explore. 3D printing foundations, 3D printing roofs, introducing new textures robotically, using design to cooperate with the landscape, using design to simplify the materials involved and the cost and the complexity of building, designing for new climate zones, designing for new cultural context, designing dignified workforce housing, designing for hurricanes and resiliency, and really pushing further on these boundaries to explore what architectural possibilities emerge when you can build things with robot and you let the humans do the creative work. I think an entirely new world is possible, and I think that world is compelling, and it is exciting, and most importantly, it is in line with our very highest and best human values. But we're gonna have to take some risks. We're gonna have to do some new things. We're gonna have to imagine things that have never been done or seen before. And I think, in the future, neighborhoods and towns and cities will be built by robots and drones, and I think that future is more diverse, more beautiful, more exciting, more equitable than the world we have today. We must do this. The housing of our future is going to be, must be different than the housing we know today. It is time to build. And I want to see an end to the global housing crisis with my own eyes. I want us to have homes on the moon and Mars, and I want us to have an exciting future, and I want these topics of homelessness and the housing crisis and housing affordability and architecture, I want them to quit being so damn depressing. I want to make them exciting again. We can have this future. It's time to build. This is the way we ride at dawn.
Please welcome to the stage Stephanie Tsai of PBS NewsHour.
Great job.
Good, thank you.
I met Jenny, your wife.
Well, then you've done the best thing you can do in Austin.
I know. Where is she? With your beautiful children. And
Yeah.
she told me a story, Jason, of how back in 2018, when you first introduced your first 3D printed house during South by Southwest, you had sort of this panicked evening where things weren't going just right with the printer. Mm-hmm. And your wife, who is a baker, helped you.
Yes, that's exactly
So
right.
let's give her
so
some credit. Tell
this may
that
surprise
story.
you all to hear. When you invent new technologies, they sometimes don't work at first. And it was the last night of construction. It was like a Thursday night leading into Friday. We were unveiling the house on Monday, and we're not even done printing. So this is our last, and we have the roofers and the framers, everybody scheduled to show up Saturday, Sunday, finish the house so we can unveil on Monday. And the printer starts clogging because the concrete had been sitting out on the job site for a bit, and it had absorbed some humidity, and there were clumps. And so those clumps would not mix, and it was clogging everything. And Alex and Evan, my two co-founders, and a few other folks who were helping us, I think we like literally sat down, and there were probably tears in eyes and that kind of thing. And my wife walked outside, it was like 2 a.m. And she's like, oh, it's like baking. And she just like ripped a window screen off the house and put it in, like started like hand sifting
it.
The concrete into 5-gallon buckets and then loading that into the mixer. And it totally worked. And we finished printing the house and we have a company. Yeah, it's, I have a lot to thank my wife for. And maybe the whole world has a lot to thank her for.
So it's been 3 years since that first house, and I went and visited House Zero today, and it is amazing.
Good.
And I also understand you've experienced quite explosive growth at Icon. Mm-hmm. So tell me where you are compared to 3 years ago. Are the printers still clogging? Do you still have to get Jenny to sift stuff?
We just opened a factory this year, and so in terms of technology, what that means is like we believe we have a version of the print technology that we're ready to stabilize, right? In the early days, you don't want to make 50 of something if it's still got a lot of problems. So we think we're approaching that moment of stability where we can start mass producing the printer so we can say yes to more of these opportunities. For a long time, we've had what I call a very sophisticated sales prevention department because we only had like 2 printers, but like tons of demand. I think we've had over 1 million homes requested at Icon, and that sounds cool if you're an entrepreneur. I wish it wasn't that many. Those emails are coming from homeless veterans. They are coming from people after hurricanes. They are coming from people living under bridges. They are coming from working class families, teachers, artists, musicians who cannot afford to live in the cities where they work, but it's that many. And so we gotta keep going, we gotta get to work. And I think we're now realizing the opportunities architecturally. I think we've got a stable, or at least approaching stable, technology stack that we're ready to start saying yes to more of these opportunities and putting more dignified, exciting, compelling homes on the ground.
Okay, but you've built some homes already that folks are living in. So what do the next 3 years look like?
So the next 3 years for us are all about, I reference it in the talk, but graduating from homes by the dozen to homes by the 100 and then homes by the 1,000. We'll continue to do some of these like exploratory experimental houses, but really we're sort of getting to a point where we won't get out of bed for less than 100 homes.
Okay.
Because we're solving a problem at scale, so the solution has to be at scale. And so we are looking for partners. If any of what I just said, the kind of world I just showed, is the kind of world you'd like to see, we are looking for people who want to do this at scale. I know some of you are in the room and we have some exciting work to do, but that's what's next. We're working backwards from 1 billion homes in a lifetime.
Okay, so I want to draw sort of a distinction between House Zero, which some of the folks in this room may have visited. Mm-hmm. It's in Austin. It's that beautiful architecturally designed home. It's a fancy home.
Yes, ma'am.
That is not necessarily what you're talking about when you say build to scale and build affordable housing, correct?
Yep, a few things going on. House Zero went so well, we've decided we're going to do more. We're going to call it the Exploration series, where we're exploring things that are not, it's not right to try out stuff maybe on somebody's house that they're going to live in. You should try it out on yourself. But that's right. House Zero was a show home, and it's expensive. And what made it specifically expensive were all the finishing choices. Mm-hmm. The wall system, if you tried to replicate that wall system with conventional building methods, it would cost you double.
Okay.
And so there's a way of taking what we learned at House Zero and deploying that into market rate and affordable housing projects. And that's exactly what we're going to use the Exploration series to do. So that's the idea.
I was looking at the renderings of your future sort of utopic vision of a 3D printed community, and it didn't look cookie cutter at all. I think a lot of people, when they think about a 3D printed home, think 4 concrete walls, and then there are some negative associations with incarceration and, concrete walls. Is that a stigma you feel like you have to overcome reputationally?
Yeah, I think, yes. I think when you first hear the phrase robotic construction, there's a potential for that to feel dystopian and scary. You've been to House Zero. What several thousand people went through that house this week, and I think unanimously what we're hearing is like, this feels more human. It feels like you had more design freedom. It feels more comfortable. And drywall, by comparison, is what feels sterile and institutional. But we have to continue to push forward because, as I said during the talk, ugly houses are unacceptable. That's not the future we want. We don't just want to build faster and cheaper. We want to, whatever we build faster and cheaper has to be desirable, aspirational, and beautiful.
And this is very American. I was thinking, and as I was researching 3D printed firms around the world, there are other countries where they are doing a lot more 3D printing already, and I think in Dubai they did the first 3D printed office.
Yep.
When I think about American home buying, I think of certain phrases like keeping up with the Joneses, forever home, trading up. Is there a cultural barrier to Americans embracing 3D printed homes in the mainstream because of these sort of ideas of what it means to have a home here?
If anybody knows the Joneses, if we could just tell them to slow down for a minute while the rest of us catch up, that would have helped make the world better. I think the main barrier to mainstream adoption so far, at like market rate housing, has been aesthetic and beauty. And so I think that's why we've begun to take that so seriously. I think people will come to see very quickly that 3D printed houses are superior to any other method at any price point to building with the conventional approaches that we have. And this is very similar to maybe what Tesla discovered with automobiles. For a long time with electric cars, they kind of look like clown cars, and they went 85 miles and probably blew up when you crash into something. But save the whales and drive an electric car was sort of like, that was like the pitch, and we were literally going nowhere on that pitch. And Tesla realized that for electric cars to become mainstream and for mass adoption, they had to be safe and sexy and fast and cool. They had to be not the best electric cars, they had to be the best cars. And we have taken up a similar challenge at Icon. Like, we don't want to be the best 3D printed home company. We don't want our homes to be the best 3D printed homes. We want them to be the best homes. Full stop. And that's how we're going to treat it.
So you bring up EVs, and that leads me to one of our audience questions, which was one of my questions as well. And that is the material that you use in the printer. Can you describe what is in there and whether it really is sustainable? Because the audience question is accurate. Why do you build with concrete? Concrete emits carbon dioxide in the manufacturing process.
Yep, I'm actually very glad this question came up. So conservation biology was my original training. It's actually the reason I got into building, was for sustainable building purposes. The stat that most people are referencing when they talk about sustainability related to concrete is that 8% of global atmospheric CO2 emissions come from the manufacture of Portland cement. And sorry if this is getting too technical, but I think it's very important to be clear on this point because the sustainability of the world's at stake. If you replace concrete with any other modern material, steel, plastic, wood, you name it, carbon emissions go up, not down. So the only other option may be to build nothing, but that seems like a very worse world. Concrete is the best option we have to build a resilient and sustainable future for humanity. That said, wouldn't it be great to decarbonize even concrete? And so we have a head of sustainability at Icon. We're actively working to reduce the amount of Portland cement in our mix. But I think even today, assume we can make zero progress. Humanity gets a lot worse without concrete and cement, and we don't have a better building material. We should be very grateful we have a material like concrete to build with.
I want to continue on the issue of sustainability and climate change for a little bit, because I also read the statistic that the construction industry is responsible for some 11% of the world's carbon dioxide emissions, and I think the UN actually says that it's more than that, up to 30% if you consider transportation, and that's a big part of your vision too,
Mm-hmm.
right? Is reducing waste, reducing transportation. Talk about how that fits into your sustainability mission.
Yeah, so the sort of, we talked about carbon related to concrete. The other sort of sustainability features of building this way, number one is concretes and mortars are largely made of like silicates and carbonates, to sort of use them to be hyper technical. Those are some of the most abundant materials in the crust of the earth. We can find them basically anywhere. And so we don't have to import our materials from all over the world. Almost anywhere we go, we can source local materials to that region. So number one, that reduces all the transport. The efficiency and comfort of the buildings in the first instance means there's less emissions and energies related to living in and operating a 3D printed building. And then the resiliency is maybe actually where I should have started. No matter what you build out of, there's a tremendous investment of resources and money and materials and energy into creating something at a house scale, especially for the whole world. And so when you make that investment, you want it to last as long as possible. And concrete is one of the most resilient materials we know how to build with. There are several thousand-year-old concrete buildings, concrete domes that have survived for a long, long time. There are concrete bridges that stand in salt water for decades. And so when you sort of amortize, so to speak, the energy and resource investment into across the lifespan of a resiliently built home versus like a drywall and stick frame, you're way ahead. So resiliency, local sourcing, and energy efficiency of operations, those are things that are like way, way, way in our favor.
I want to jump to space while you're on the issue of the core materials in the Earth, because those are not the same as the ones on the moon.
Yeah. Well, they're not radically different. So I mean, we think the moon was created when a small planetoid crashed into the Earth and knocked off part of our crust. And so the materials actually on the moon are very similar to the materials in the crust of the Earth. That said, there's not a lot of water. Turns out there's probably water, but you would never build with it. You need it for life support and rocket fuel and other things. It'd be like if you built a home out of like platinum here, you would tear it down to get the platinum out. If you built a moon base out of water-based concrete, you would tear it apart to get the water out. And so we're going to have to find a way to build without using water. And so the way we're going to do that, you may have seen, or you may have asked yourself, what were some of those videos about? We're going to have to take moon dust, scientists call it lunar regolith, and directly deposit energy to melt or sinter it. Our favorite two approaches so far are lasers. So we have basically like a weapons-grade laser back at the lab where we've had a lot of success building object out of moon dust.
That's what you're doing at Johnson Space Center?
That's what we're doing at our lab here in Austin.
Okay.
And then we've also had a lot of luck with just direct melting through like a resistive or inductive furnace. And so we have several options that we think are very viable to take moon dust and make very strong building materials out of it. Like the technology is like very near term. Like we could absolutely build a moon base in our lifetime. We could get started this decade. And in fact, ICON is scheduled to have our first systems in space in 2 years. And we're presently scheduled to be on the surface of the moon in 2026.
Where do you get the moon dust now that you're using?
Great question. Great question. So the Apollo astronauts brought back several kilograms or dozens and dozens of kilos of lunar regolith back during the Apollo missions. That's all stored in Houston. And we can study those materials and use it to make simulants. We can make a simulated moon dust. I think we will actually be able to get our hands, if we continue to make the progress we're making, on actual Apollo samples, which will be kind of cool. But right now we're using simulants.
You can go to like one of those souvenir stores and just buy all the little
that's
rock
right.
things and
That's exactly
put them
right.
in your printer. How fierce is the competition for designing the base camp as part of, I know you've partnered with NASA, but I know that there's starting to be more and more 3D printing firms. What makes yours more competitive?
Ours works.
Of course you're going to say that.
That sounds mean. One thing that maybe I should have led with. I am generally, in the first instance, a fan of anyone trying to produce any more housing by any means. I'm a fan. And they're sort of like a same team. So the competition is a friendly competition to create a better outcome for humanity. There's a lot of decisions that we've made along the way that I think have made our technology better. I think we've delivered dozens more structures and homes than any other company that we are aware of, especially if we say like permitted homes and structures.
Right.
But I welcome the competition, and I think more people should be building houses. But I think we made a few key decisions about the function, the form of the printer, the decision to take material science in-house and take it super seriously, and actually the decision to treat the houses themselves like a product and to take architecture and building performance very seriously. Those are a few of the kinds of decisions that some of our competitors made other decisions that have, I think, made their job harder, because it's already pretty hard.
Well, I want to go back to those issues, but from space to a very earthbound problem that I know you care about, Jason, because when I interviewed Jason for our PBS NewsHour piece, one of the first things he said was, I worked at a homeless shelter out of college. And, you know, that made you very interesting to me because you are a technologist and a futurist who is also a humanitarian. And so I wonder if you'll talk about what really drives you to do this.
Yeah, this is all very personal for me. My hometown has been destroyed by hurricanes multiple times. I've torn sheetrock out of my dad's house, only to put it back with more sheetrock to get destroyed again by the next hurricane. My first paying job out of college was a program staff at a homeless shelter in Boulder, Colorado. And the first business I started was a sustainable materials and building products company. Where does it all come from? I was almost a priest. Had actually been accepted to seminary when my first business in building and construction was called Treehouse Sustainable Buildings and Materials. They got funded, and so I went to the Bishop of Texas and I said, "What do I do? I'll do whatever you say, basically." And we talked and prayed, and Jenny was with me. Went out to lunch, went back to his office, and at the end he said, "I want you to treat. I can just tell you care a lot about housing, and I want you to treat the problems of housing like that is your vocation, like that is your life." And he blessed me and said a prayer over me, and that's what I've been doing ever since.
And don't think I didn't notice that you opened your speech with Ecclesiastes.
You caught that.
And
Yeah.
in the season. So clearly your faith has intersected with your mission here. How affordable really is it right now to 3D print an affordable house? Is it really half the cost? I know that some homeless advocacy organizations, not necessarily with your company, but they have started looking into 3D printed affordable housing.
Yep. I hope I can take a minute maybe to answer this question, because it actually is quite complex. People often want the answer, what's the percentage? Often reporters.
Yeah, sorry.
So first of all, I don't think any method or organization on earth, to be very clear, can deliver the quality of house and wall system that Icon delivers faster or cheaper. I think that's true today. The important modifiers really the important modifier is the quality question. So down in Mexico, for instance, I don't think we were cheaper in Mexico. They pay laborers $1 or $2 a day, and the foundations they were building on those houses were book thick, on construction projects down the road. I can't compete with that, and I actually don't even want to.
Because the quality is subpar. Yeah.
Correct, and so that's an extreme example. If you want a house that'll survive the seismic effects, that'll create a comfortable building environment for the Mexican families who live there who don't have HVAC systems, that enables you to incorporate architectural beauty and dignity into the project, if those things really are stable stakes, and we're not going to throw those things away like they don't matter, we're fastest and cheapest. The other thing that we've discovered can be a real important factor is this design for 3D printing. If I sort of walk up and print your regularly shaped square house with the walls exactly that you're used to, that process and those designs were optimized for that approach to building across centuries, which is why this House Zero project was actually so important. It was we can't play the game on the terms of the technologies we're trying to displace. We have to play the game in a way that plays to our strengths. And so House Zero, because I hope the script flips, right? Where people eventually point at 3D printed houses and goes, who else can give this homes like this faster or cheaper? And the answer is nobody. because those walls are beautiful and strong and energy efficient. And as I said earlier, we had a construction friend of ours come to House Zero and said, how much if you had to build this house with the wall system with conventional building? And he said double of what it actually cost us. And so that's all layered together. But that's only after 4 years. And we're about to do a big partnership with Lennar, who is the very best production scale home builder in the world. And we're going to try to save them money and time. And then we will know where we are. And if we can do it with Lennar, then we've done it with the best. And
so Lennar is 100 homes. So part of it is just sort of economies of scale, and that's when you might see that half price situation.
Yeah, the scale is going to be important, but the other thing that you raise is it's not just going to be 3D printing. You've noticed during the presentation I said that Icon's a construction technologies company. I referenced our software. There's a lot more digitization and automation to come. We started with the wall system for very specific reasons, but now we need foundations and roofs and all the other things that go into a home. We need to digitize design and structural engineering and permitting and the whole process end to end. When you start adding all those things together, you save 5% on permitting time, you save 3% on structural engineering, you save 10 or 30% or 50% on your wall system. You start adding those things together, that's where you start really being able to imagine a world delivered in half the price, at half the price and in half the time, and the houses are twice as good, and the twice as good part's important too.
Okay, I want to take this audience question from Danielle Johnson because it's kind of related to the business. Is your plan to continue to partner with builders or to become direct to consumer?
Yeah, I think it's a little bit complicated. To get to this sort of billion home number, I think that means we have to, at some point, begin putting this technology into the hands of other builders and people. And we are excited that Lennar and others have raised their hand and said, we want to innovate in these ways. And we hope there will be more of that. But it turns out I'm the kind of CEO, it matters to me what our technology is used to build. And that doesn't seem to always be the case.
What do you mean by that?
Some of the other 3D printed houses are terrible. They are very ugly, and no one sitting in this room would want to live in them, or would certainly not take a mortgage on them. And apparently that's fine by those, because they're letting it happen. And we have, and I think we'll continue to have this very interesting, at least direct-to-consumer awareness. It really matters to us. Even if I one day can sell a fleet of printers to Lennar, it will matter to me what the experience of the people who live in those houses is like, even if I wasn't directly selling to them, if that makes sense. And so there's probably some business model innovation in front of us to get there, but I'm simply not willing to compromise on the quality of homes that are built. And so how do I control the outcomes for customers when I'm selling to builders and developers? It's probably complicated, but
you'd like to maintain some control over that.
Yep, and there's some cool models for this out in the technology world. Apple has the App Store, and you can't put dangerous or unsafe or terrible software applications on the App Store. It's kind of it's an open garden, but it's patrolled, if that makes sense. There's probably a way to create an open-ish ecosystem that we patrol, and then everybody wins, right? I think there's going to be tremendous. I hope people are asking for Icon homes by name. And then Lennar and others get to raise their hand and go, we can deliver those. That would be a really happy outcome for us, I think.
Do you have to sacrifice, so again, going back to House Zero, which was just so stunning, that there was a lot of wood in the interior. There was, I think there was Douglas fir, there was a beautiful glossy concrete floor, and I think there was also wood paneling on the roof. Does any of that sort of undermine the main point of a 3D printed house, which is speed and cost efficiency?
Yep, perhaps, but I think we do have to make a journey with people to get them to I think one of my, or you see some of them, if you want to show the video of the city of the future or whatever, if that pops up, you'll see those are 100% 3D printed, if you can, there you are. It's going to take us a minute to get there. Again, to invoke Tesla, the early Tesla cars still had a grill in them. You don't need a grill to cool the radiator in an electric car. But people were used to having grills, and they wanted their grills, and that was fine, and you sort of make a journey. We'll kind of have to make that journey of innovation as well, where it's to get to where you want to go, you have to start where you are. And so But I think you can see it's like not so bad to imagine a 3D printed future. So,
How many printers do you currently have? And how do you get them around the country
yeah,
to print the home?
great question. So we opened the factory in the middle of last year. Opening being a euphemism for like building robots while still building the factory. If that counts as an opening, that's what we did. We'll have about a dozen of them that will get completed this quarter, and then we'll try to kind of keep that cadence up going forward. And so dozens and dozens of new printers at our present capacity could come online every year as we say yes to more and more projects. But eventually, there need to be millions of robotic construction systems in the world. That sounds like a big number. There's way more cars and tractors and things like that than that in the world already. So we know that we can make robots and machines at that scale. We know we can do it.
Okay. Now, all of this is proprietary under Icon's roof, right? Including the printers and the software and the app on the phone where you can actually print the house from there. How does that give you an advantage in the 3D printing?
Yeah, it definitely, I think, creates a tighter experience for the people who we're working with. We help handle design and architecture. We guarantee our materials. We guarantee that the robots work. We guarantee that the people who show up and operate those printers know what they're doing and are going to do a good job. And so it really helps us fulfill the ambitions of the technology at a very, very high quality level. This is so important to get right. We just felt like we couldn't take any chances. This is probably the most expensive way to do it, which is probably a great reason that some of our competitors haven't done it this way. This is the most expensive way, is to get into your own concrete batch plant, to make your own robots, to field your own teams, to do your own architecture. But it just felt too important to leave anything to chance.
Okay. This is a related question when it comes to the printers from the audience. What other applications do you see as a trend besides social housing for the use of your 3D printing technology?
Yeah, social housing is certainly the one that I think everybody at the Icon team feels the best about. But ultimately, the housing crisis doesn't stop just at homelessness and affordable housing. Like market rate affordable housing in all of our cities, homes at every single price point being sustainable and beautiful and resilient. I mean, we really do. When I say paradigm change, I mean paradigm change. And so I think this is a technology that wins at every price point of home. But then some of the other things that are certainly in front of us will be building other things, as you've seen in the video. We already are starting to get some early requests for commercial buildings, for requests for different types of infrastructure. Again, I think in the future, whole cities will be built by robots and drones. So that's coming.
People freak out a little bit, maybe not at South by Southwest, but when you talk about robots and drones building everything. Even though I know that there is a shortage of labor in construction right now, so that might actually be not a bad thing to have right now, but how do you address those concerns?
Yeah, maybe they do freak out sometimes. I wish they would freak out about the housing crisis. I'm freaking out, and that's what got me to robots. Because there's simply, as I said, I think every person already who knows how to build a home is gainfully employed doing so, and we're getting 2 million behind per year. And so the world is a lot worse if we don't jump to advanced technologies than it would be if we keep doing it the way that we are.
When you go to a construction site for your 3D printed home, I guess you don't call it a construction.
Yeah, job site.
Okay, a job site. What does it look like? How many people are on the ground? What types of technicians do you need if something goes wrong with the printer?
Great question.
Who's there? Or can your children do it on their app? I mean, what's required?
We definitely have had some people walk up and put the tablet in their hands and just to see if they could make it. It's like fairly intuitive to make it do what you need to do thanks to our like very talented control software and design engineers. But you lay down the rails for the printer goes on rails. And then with the printer, we haven't talked about it, is a material delivery system that makes our proprietary extrudable concrete in real time as the weather changes. Because concrete responds quite dynamically to changes.
So it's mixing it, the printer is actually mixing it and formulating it before it squirts it out?
Yeah, not the printer, the material delivery system that then pumps the material into the printer, and then the printer prints the beads layer by layer. Okay. That machine is called the Magma, and it's very important to be able to print in all kinds of weathers so that you can go as fast and affordably as possible. And so you have a mantle, you have a printer, and then typically what we have today is a designated printer operator, a designated magma operator, and then a number of people playing support roles. That's where we are today. So typically like a skeleton crew today, an absolute skeleton crew, I think we did like Mexico. At some points we had as few as 3. That's very uncomfortable. I think 5 or 6 is like more standard size crew today. We have a big project underway called Project Autopilot at ICON. The goal of Project Autopilot is to ultimately, well, to say it in the most romantic way possible, imagine somebody was sitting back here in Austin and was monitoring a fleet of robots somewhere else. That's sort of the grandest future state. And we'll sort of have to automate our way into that future state. So truly, neighborhoods built by robots is what's coming.
What kind of skills do the 3 or 4 people need?
They need to be very skilled at having a positive attitude, resilience, and innovation. If you've got that, if you don't mind,
you can get a job at ICON.
If you don't mind moving at a high velocity, if you are highly ambitious and highly courageous, we got a job for you.
I'm curious how you've been affected by the supply chain shortage that seems to be affecting other traditional construction companies.
Yes, I remember telling my board of directors at our Q4 board meeting last year, no problems, everything is fine. And then we got back to Q1 this year, and it has been kind of hand-to-hand combat all of Q1. Some of them are in the audience fighting this out for the first time. We finally did, like, the supply chain that's affected us most is the supply chain to manufacture the printers. Some of our motors and computing components have been difficult to get a hold of in the last few weeks, really. On the construction side, we use far fewer materials in the wall system than a conventional wall system. And so we do not expect, as we do this 100-home community coming up, that our challenges will be nearly as significant as the supply chain crunches that a lot of the other conventional builders are facing right now, and they are profound.
Do you think there's an opportunity even?
I think add to the list of advantages of 3D printing that I've already said, add supply chain simplicity as like yet another advantage. So.
In just the final few minutes of our conversation here, I wonder if you can dispel any myths or misconceptions people may have about 3D printed houses.
Yeah, there's no $4,000 houses. That's an important one. The first article that ever ran about ICON was Austin company delivers $4,000 house, and I think that was like a game of telephone of like, that concrete cost $4,000, that turned into that house is $4,000, and that was like, this is gonna solve the American housing crisis. And the truth was, the concrete was $4,000 before the additives. That was for a tiny house in a Mexican context. It was sort of like, it was like a game of telephone. To this day, people call and ask me for their $4,000 house. Nobody would be more excited to give you a $4,000 house. Or maybe here's a game we could play. I'll start printing until it hits 4,000, and I'll stop, and we'll see what we have. I think we are faster and more affordable. We're not quite $4,000, so maybe that's a good myth to dispel.
Isn't another one that people say, how am I gonna hang a picture?
Oh yeah, people do ask that a lot. It's funny what people ask. It's like, we're worried about so many things. It's like, where do I hang the picture? Masonry and concrete construction has been around for a long time. And so you use masonry screws or masonry nails to hang up whatever you want. And when you're done, you can patch it. It's about as simple as patching drywall, because you also make a hole in the drywall when you hang a picture. So that one, thankfully, has an easy answer.
And I guess my final question is, again, as you sort of shoot for the moon, Jason, but also try to address suffering here on this planet, how do you reconcile, and can you reconcile those things as being part of the same mission and vision?
Well, you brought up suffering, so if I could take a moment of just like personal privilege. There's a lot of suffering going on in Eastern Europe right now that's on my mind as we think about suffering in the world. There's a lot of reasons to be pessimistic about our future. My heart and prayers are absolutely with people suffering there and everywhere right now, and I hope ICON can be some kind of beacon of hope, that that human beings can be amazing, and that our human situation is worth fighting for and defending. So just to say that. The seeming contradiction of the moon and homelessness. Humanity has always been at its best, and it's most innovative when attempting grand things. And I think, I have come to believe, that it will take a spacefaring civilization to solve homelessness, because space is the deep end of the pool. And if we can figure out, you want to talk about sustainability, you can't waste anything in space. If we can figure out how to build on the moon and Mars, that will accelerate the development of the technologies we are going to need to solve all these problems. And as my friend Bjarke Ingels says all the time, it might just be the strangest thing that the answers to some of our problems on Earth will be found on the moon. And I have really come to believe that. I think we have to get out of this false dichotomy that either we solve that problem or pursue that opportunity. I think the most exciting possible future, we shouldn't be pursuing like a minimalist future. We want to pursue the most exciting possible future. And the most exciting possible future is this, maybe we could end with the video up again, because I like it so much. And it has the moon in the video as a little Easter egg. The most exciting possible future is a diverse, sustainable, beautiful cities all over this planet, and a moon base up there in the sky. That's the most exciting possible future, and that's the world we're trying to build at ICON.
Jason Ballard, co-founder of ICON, thank you so much.